welcome to this page. This is brought to you by Weirdba. Weirdba is an online virtual tutoring platform where you can actually learn remotely. That is at the comfort of your room. You can always have class schedule. So it's an update and upgrade of the traditional physical classes. So as such, busy schedule cannot be an excuse. So you can always have a flexible classes that is actually tailored to your schedule. So reach out to find out more about us, and also like the page, share with your friends, subscribe, don't forget. So I'm going to walk us through different problems, and I'm going to cover solutions, and it's going to be very elaborate as much as possible. It's going to be systematic, and as much as possible we'll ensure that also the mathematical standard also is not compromised in the process. So now look at what we have here. We have to prove by using mathematical induction that this expression is a multiple of 9. So let's have the proof. But first, let's understand the problem. Now this is expression. They say it's a multiple of number. When you say something is a multiple of another number, that means I can express if I have, let's say, a number, let's say k is a number. If I say it's a multiple of m, that is, I can write m multiplying a and any integer, call it maybe a be an integer. Or simply put, it means that m is actually, when you say m is a multiple, k is a multiple of m, so it means that m is actually can divide k without a remainder, and that implies that if I divide through by m, the result I'm going to have here will give me a whole number, that is it's an integer. An integer is whole number value, both positive and negative, is 0 inclusive. So when you have -3, -1, 0, 1, 5, they are your integers. Alright, so let's start. So if this claim, the claim is that it's true, now it means for any value of n, this expression will always be divisible by 9. Now this is quite an audacious statement. I would call it a universal statement. So that is, no matter the value of n you give me, then I'm sure it will always be true. Now, how best do we actually come to prove this? Now let's even start from the very first natural number. That's n equal to 1. From this part of the world, we start our natural number counting from 1. So let's see, is it true for n equal to 1? So if it does hold for n equal to 1, so you might actually want to check for others. So let's check. Now check for n equal 1. So that expression, we have 10 power of 1 plus 3, 4 power of 1 plus 2, that's 3, plus 5. And what's that? That's 10 plus 3 times, that's 64, plus 5. And that's 10 plus, what's 3 times 64? 3 times 60, 180, 3 times 4, 12, that's 192. So 192 with 5, that's 207. Now if I'm to divide 207, is it divisible by 9? That is it multiples of 9? Yes, it's true. 9 times 9 in 20, that's 2, 9, 27, that's 3. So 9 times 23 really is actually the value of our 207. So hence it's true for n equal to 1. Now the next thing that might come to your mind is that, oh, let's also show that it's true for n equal to 2, then n equal to 3. We don't have that luxury, because if you had to actually try that part, it means that you have to show for 1, 2, 3, 4, 5, and your natural number is, they are actually finitely, they are countably infinite. That is, you can't actually tell where it stopped. So as such, you have an endless proof to actually to carry out if you have to trade that part. So instead, what do we do? And that's the principle of induction. Let's suppose it's true for n equal to k, where k is a natural number. So that is, let's suppose I true for any k. K could be any value, any natural number value. It could be 1,000, it could be a million, it could be 100. So that is, so that means that the expression 10 So there is power of k plus 3, 4k plus 2 plus 5 is a multiple of 9. When you say multiple of 9, that is 9 multiply a particular integer. Let's call it m. So m is an integer. So that's what it means, that it's a multiple of 9. So now with that said, so that let me do something, and you're going to see why I want to do that eventually. Let's make 10 power of k such the formula. So I have 10 power of k to be equal to 9m negative 3 4 power of k plus 2 negative 5. You can call this star. Now the next thing is now that we would check if our supposition for n equal to k, if the truth for k, now if it's going to be true for n equal to k plus 1, really intuitively what are we trying to do? Now look at it this way. Remember we said we want to show that it's true for any natural number. Now if we could establish that the truth for k is also implies that it's true for k plus 1. What does that mean? It means to be true for n. Now look at it this way. That means that if it's true for k equal to 11, then it's going to be true for k equal to 11 plus 1, which is 12, and which is also be true for 12 plus 1, which is 13. And it follows out. That means if it's true for 1,000, it's going to be true for 1,001. If it's true for 10,000, it's going to be true for 10,001, and it continues that way. So as such, it gives us that sequence that it will always be true for. So hence, if we are able to justify that it's going to be true for k plus 1 when it's true for k, then we can say it is true that this particular expression is actually divisible by 9, that is a multiple of 9. So that is what we now want to show. That is, so that means when n equal to k plus 1, that is 10 power of, when that will be k plus 1 plus 3 into 4, that will be k plus 1, then plus 2, then plus 5. We want to show that this guy here is actually, it's a multiple of 9. So let me call this expression, let me just represent it by something. Let's say, let me call it h. So now let's take it one after the other. So what we intend to do is that h can be expressed as a multiple of 9. So let's see, are we going to eventually come about that? Let's look at that. So now if I write that, so I have my h to be equal to, that's 10 power of k plus 1, 10 power of k plus 1 plus 3 into 4. If I write that together, that will be k plus k plus 3, then plus 5. I can rewrite this as, this is 10 power of 10 into 10 power of k, law of indices, plus I can also write this as 3 into 4 into 4k plus 2, then plus 5. Now what have I simply done? This is simply like power of 1. So 1 plus 2 still takes us back to where we have here originally. So we have 8, so 10. Now recall, we said 10 power of k is what? Is what I have here. So that's 9m negative. So let's have that. So this guy here, let's have it. So let's put it here. So let's paste it here. Okay, good. All right, perfect. So now this is 3 into 4k plus 2, then negative 5, then plus, so I've replaced this is this, then plus this, that's 3 times 4, that's 12, 4k plus 2, then plus 5. Now if I open that up, I have 90m negative 30 into 4k plus 2, negative 50, then plus 12 into 4 k plus 2, then plus 5. Now this is similar, so we have that as 90m, that is negative 18 into 4k plus 2. Now this negative 50 positive 5, that's negative 45. Now here we have 9 coming all through, so I'm left with 10m, negative 2 into 4k plus 2, negative 5. Now look at what we've done. Maybe you don't see it. Now m is an integer. Now 4 power of k plus 2, no matter the value of k be a natural number, this also will be an integer. Now the whole of this expression is nothing also but an integer. Let's call it another integer. Let's say integer, let's say u will be an integer. Now what have we shown? So this means that age is equal to what? 9u. That is, age is a what? Is a multiple of 9, which means our, what was age original, that is for n equal to k plus 1, that is, it is true for what? N equal to k plus 1, since the expression that it gave us age is actually what? It's a multiple of 9. It's true for n equal to k plus 1, that is our initial expression, that is, that's 10 k plus 1 plus 3 into 4 k plus 3 plus 5 is actually what? Is a multiple of that. Is a multiple, that's 9, so it's a multiple of 9. 10m negative 2 4k plus 2 negative 5. Now it means that what? It's true for what? It implies that it is true for n equal to k plus 1. So now by induction, so what are we going to, how do we conclude it? So now, since the truth for n equal to k implies the truth for n equal to k plus 1. It therefore implies that the expression, the original expression we had, which was, let's have that copied out. This expression, that particular expression, so this expression, this is for n equal to k plus 1, then it is a multiple of 9, and which conclude our proof. Now continue from there, and we'll take the next question, the next video. So don't forget, ensure you share, like the page, and also ensure you subscribe. Thank you.